Somewhere out past Neptune, a frozen little world that most people wrote off 2 decades ago just handed scientists a signal that does not match anything in the known chemical record. Not a molecule they misidentified. Not a molecule they forgot to double-check. A signal with no match at all, appearing in exactly the same place on 2 completely different worlds. And nobody currently has a clean explanation for it. Stick around, because I am about to walk you through exactly what James Webb found on Pluto, why it is making planetary scientists nervous in a good way, and why this one discovery is different from everything that came before it. And if you want more of these deep dives into real published space research, hit subscribe now, because this channel does not chase headlines. It chases the actual data behind them. And let's start with why anyone still cares about Pluto at all. For most of the last 20 years, Pluto has carried a kind of reputation it never really earned. In 2006, the International Astronomical Union voted to strip it of full planet status, reclassifying it as a dwarf planet, and in the public imagination, that vote basically ended the conversation. Small, cold, demoted, forgettable. That was the story most people walked away with. But researchers who actually study the outer solar system never treated that vote as a scientific verdict on how interesting Pluto is. It was a definitional argument about categories, not a discovery about what Pluto is actually made of or what is happening on its surface. And once real instruments finally got a close look, that distinction became impossible to ignore. The first real look came in July of 2015 when NASA's New Horizons spacecraft screamed past Pluto after a 9.5-year journey across roughly 3 billion miles of empty space. It had one shot. No orbit, no braking. Just a narrow window of a few hours to gather everything it possibly could before continuing on into the darkness of the Kuiper Belt forever. What it sent back did not look anything like the dead, cratered ice ball scientists were expecting. There was a massive pale plane shaped unmistakably like a heart, smooth and geologically young in a way that made no sense for a world supposedly frozen solid for billions of years. There were mountains of solid water ice rising more than 10,000 feet into a hazy sky. Mountains hard enough at those temperatures to behave more like bedrock than ice. And wrapped around the entire planet, layer after layer of blue haze rose hundreds of miles above the surface, visible even when backlit by the distant sun. New Horizons proved Pluto was active. What it could not do was explain why. That is where the story usually stalls in most retellings, because after that single flyby, there was no way to keep watching. New Horizons kept flying outward, never to return, and for years scientists were left arguing over models they had no real way to test. What they needed was not another photograph. They needed a way to read Pluto's chemistry directly from 4 billion miles away, continuously, without ever sending another spacecraft. That is exactly what the James Webb Space Telescope was eventually built to do. And it is worth understanding briefly why Webb succeeds where ground telescopes failed for decades. Webb does not fly past anything and snap a picture the way New Horizons did. It reads light itself, breaking it apart into individual wavelengths to expose the precise chemical fingerprint of whatever it is staring at. The problem is that Pluto sits so close in the sky to its largest moon, Charon, that separating their individual heat signals used to be practically impossible. Earlier infrared telescopes simply could not tell how much of the detected warmth belonged to Pluto and how much was bleeding in from Charon, sitting right next to it. Webb's much larger mirror and far more sensitive mid-infrared instrument, known as MIRI, finally solved that specific problem starting around 2022. And once scientists could cleanly isolate Pluto's own signal for the first time in history, the picture that came back was stranger than anyone expected. If you appreciate space content that actually explains the instruments instead of just showing pretty pictures, drop a like right now. It genuinely helps this kind of breakdown reach more people. The discovery drawing the most attention right now did not come from a dramatic photograph at all. It came from a gap. In the summer of 2026, a team of researchers combing through Webb's infrared spectra of both Pluto and Saturn's giant moon Titan noticed something odd sitting in a wavelength range nobody had paid much attention to before. At approximately 5.11 micrometers, both worlds showed a distinct dip in their spectrum, a place where something was clearly absorbing infrared light. That kind of absorption line is normally how scientists identify exactly what a surface is made of, because every known molecule leaves its own specific fingerprint at its own specific wavelength. So the researchers did what any careful team would do. They went back through the published literature on planetary spectra, cross-checking every documented absorption feature at that wavelength across the solar system and beyond. They found nothing that matched. Not a known ice, not a known hydrocarbon, not anything cataloged from exoplanet atmospheres either. The signal was real, it was consistent, and it belonged to no known substance. What makes this particularly hard to wave away is where the researchers believe the signal is actually coming from. Based on how it behaves, The absorption appears to originate from material sitting directly on the surface of both worlds, rather than from gas floating in their atmospheres. That distinction matters enormously. An unidentified atmospheric gas could plausibly be some exotic trace compound cycling through a thin envelope of air. An unidentified surface material is something else entirely. It means there is solid matter sitting on the ground on two separate worlds, 4 times farther apart from the sun than the other. That does not match anything chemists have cataloged before. And here is the detail that tends to stop people once they actually sit with it. Pluto and Titan are not similar worlds. Titan is larger than the planet Mercury, wrapped in a thick nitrogen atmosphere, and is the only other place in the solar system known to have stable liquid on its surface. In Titan's case, rivers and lakes of liquid methane and ethane. Pluto, by comparison, is roughly half Titan's size, has an atmosphere so thin it is closer to a vacuum, and sits in a completely different region of the solar system. On paper, these are two very different environments, yet somehow the exact same unexplained fingerprint shows up on both of them. That kind of overlap does not usually happen by coincidence in planetary science. It usually means there is a shared chemical process happening on both worlds that scientists have not identified yet, something with a common origin story that nobody has written down. The differences between the two signals are just as telling as the similarities. On Pluto, the absorption feature is roughly 3 times stronger than it is on Titan, suggesting whatever this material is, there is simply more of it sitting on Pluto's surface. On Titan, the signal is not spread evenly across the moon either. It shows up more strongly on the hemisphere that trails behind Titan as it orbits Saturn than on the hemisphere that leads the way. A pattern that hints the material might be forming through some kind of ongoing process tied to how each hemisphere is exposed over time rather than sitting there as some ancient static deposit. Researchers currently have a short list of candidate explanations they are testing, including forms of benzene mixed with other compounds, frozen acetylene, and frozen ketone, but every one of those remains a guess rather than a confirmed answer. The honest, and frankly more exciting, position right now is that nobody knows exactly what this is. It helps to understand briefly how astronomers actually confirm that a signal like this is real, and not simply an instrument glitch or a processing artifact, because that step matters just as much as the discovery itself. Every Webb spectrum passes through extensive calibration before scientists ever start interpreting it, comparing the raw data against known reference sources and repeated observations to rule out anything caused by the telescope itself, rather than the object being studied. In this case, the same absorption feature showed up independently in separate observations of Pluto and in separate observations of Titan, taken at different times, which is exactly the kind of repeatability researchers look for before they are willing to call something a genuine discovery rather than noise. That is part of why this particular finding is being taken seriously instead of dismissed as a fluke. It was not a single strange reading. It was a consistent, repeatable feature that simply refuses to match anything already in the books. Why does an unidentified surface chemical on 2 icy worlds matter beyond simple curiosity? Because Webb has already proven itself extremely good at identifying known molecules in exoplanet atmospheres light years away, tracing water vapor, carbon dioxide, and methane around planets orbiting other stars entirely. Finding something Webb cannot immediately identify, sitting on 2 objects within our own solar system where scientists have direct, high-quality spectra to study for years to come, is a genuinely rare situation. It gives researchers a nearby laboratory to actually run down the mystery instead of squinting at a signal from hundreds of light years away that they may never resolve. There's even a future mission that could eventually settle part of this. NASA's Dragonfly mission, a rotorcraft lander scheduled to launch no earlier than 2028 and expected to arrive at Titan in the mid-2030s, will carry instruments capable of directly sampling surface material. If Dragonfly identifies whatever is producing that signal on Titan, scientists will finally have a real candidate to test against Pluto's matching feature from 100 million miles farther out. This is not the only reason Pluto has been raising eyebrows recently. It sits inside a growing pile of behavior that, taken together, paints a picture of a world far more chemically alive than its demotion in 2006 ever suggested. Researchers had already confirmed something almost as strange a year earlier, when a team using Webb's infrared instruments verified that Pluto's upper atmosphere is being actively cooled by the same blue haze New Horizons first photographed back in 2015. The idea had actually been proposed back in 2017 by a planetary scientist who argued that unlike similar haze on Saturn's moon Titan, which traps heat and warms the surface below it, Pluto's haze might be doing the exact opposite, absorbing sunlight and radiating that energy straight back into space faster than Pluto's paper-thin atmosphere could ever hold on to it. When Webb's data finally came back, the numbers lined up almost exactly with that 8-year-old prediction, and Pluto's upper atmosphere turned out to be roughly 30 degrees Fahrenheit, colder than earlier models had assumed. In effect, Pluto is not simply cold because it sits so far from the sun. It appears to be actively refrigerating itself using nothing but particles suspended in its own sky, something researchers now describe as a genuinely new kind of planetary climate, unlike anything else observed anywhere in the solar system. Even the chemistry drifting down from that haze tells its own strange story. The faint trickle of sunlight reaching Pluto is still enough to break apart methane molecules high in the atmosphere, and those broken fragments recombine into heavier reddish-brown compounds called tholins, which drift down and settle onto the surface below. That process has apparently been running continuously for roughly 4 billion years, a slow, uninterrupted snowfall of organic building blocks landing on a world simply too frozen for any of it to ever spark into life. Scientists studying the origins of life on Earth care about this because it gives them an active, observable version of a chemical process that, on our own planet, finished playing out billions of years ago, leaving behind only indirect evidence. Pluto, in that sense, functions almost like a working laboratory for the raw ingredients that may have once seeded life elsewhere. None of that organic material simply stays on Pluto either. For billions of years, methane, and other light molecules have been slowly leaking off Pluto's weak gravity and drifting across the roughly 12,000 miles of space, separating it from its largest companion, a battered ice moon named Charon. Charon's surface is mostly unremarkable water ice except at its poles, which are stained a deep, unmistakable reddish-brown, unlike anything else on the moon. Researchers eventually confirmed that this coloring comes from exactly the escaping material drifting over from Pluto. Because of the way Charon is tilted as it orbits, its polar regions spend multiple decades in complete darkness, turning each pole into an extremely effective cold trap, where escaping methane freezes solid onto the surface. When sunlight finally returns to that part of the moon, ultraviolet radiation and cosmic rays break the frozen molecules apart and reassemble them into heavier, darker compounds, locking that coloring in permanently. Two worlds, locked together in a slow ongoing exchange of atmosphere and color that has apparently been running quietly since long before either one had a name. Charon has kept producing surprises of its own even outside that exchange. Researchers using Webb data confirmed the presence of both carbon dioxide and hydrogen peroxide frozen directly onto Charon's surface, a chemical combination never previously confirmed there, with the carbon dioxide likely exposed by ancient impact craters, and the hydrogen peroxide apparently formed through years of radiation striking the moon's water ice and rearranging it into something new. And in a separate line of research published just this year, scientists studying Charon's rotation found evidence the moon is still gradually losing angular momentum even after billions of years locked in its tight orbital relationship with Pluto. A slow, ongoing process most models assumed should have settled into a fixed, unchanging state long ago. Every time researchers look closer at this pair of worlds, something that was supposed to be finished turns out to still be quietly in motion. If you have made it this far, and you are finding this as strange as I did while researching it, drop a comment and tell me, because it genuinely helps me figure out which space stories are worth digging into next. Picture for a moment what all of this would actually look like if you were standing there. The sun would appear only as an intensely bright point of light, smaller than a pinhead held at arm's length, giving off no real warmth. The sky would sit in a permanent grayish-blue haze, never fully day and never fully night. At nearly 400 degrees below zero, water ice stops behaving like ice at all, and instead behaves closer to solid rock, hard enough to ring almost like metal if struck. And in a region researchers named Tartarus Dorsa, New Horizons photographed something no spacecraft had ever documented anywhere else in the solar system: towering rows of jagged ice blades made of frozen methane, some reaching more than 1,500 feet high, arranged in long parallel ridges. A 2025 reanalysis of that original data suggests these blades may wrap around as much as 60% of Pluto's equator, forming an entire ring of jagged frozen terrain circling the planet. South of that famous heart-shaped plain, two enormous isolated peaks rise out of the landscape that researchers still cannot fully explain. One stands roughly 13,000 feet tall, the other may reach close to 20,000 feet, with deep depressions at their summits and lumpy, uneven flanks that closely resemble cooled lava flows. Except there is no molten rock anywhere on Pluto. If these features are what they appear to be, they are cryovolcanoes, structures that once erupted with a thick slurry of water, ammonia, and methane forced upward from somewhere deep beneath the icy crust. That kind of internal warmth leads directly into one of the most debated ideas surrounding Pluto today: the possibility of a hidden ocean buried roughly 100 miles beneath the surface, kept liquid by the slow radioactive decay of elements inside Pluto's rocky core. The evidence is not a photograph, it is a pattern. Cracks and ridges across the surface that line up the way you would expect from a subsurface layer of liquid shifting slowly beneath the crust, Sitting directly under that same pale heart-shaped plane where a positive gravity anomaly suggests something denser than surrounding ice may be concentrated underneath. Scientists find that scenario compelling because similar hidden oceans are already strongly suspected beneath the icy surfaces of Europa and Enceladus, moons of Jupiter and Saturn that show far more obvious surface evidence, including active geysers erupting directly into space. If a body as small and as cold as Pluto turns out to be hiding something similar, it would suggest buried oceans are a far more common feature of icy worlds throughout the outer solar system than scientists previously assumed, rather than a rare exception limited to a handful of larger, more actively studied moons closer to the Sun. Right now, there's no funded mission planning to send a probe back to confirm any of this directly. Outer solar system missions are extraordinarily expensive and extraordinarily slow, often requiring a decade or more of travel before a spacecraft even reaches its target, and space agencies generally have to weigh that against closer missions that can return results within just a few years. That trade-off means Pluto keeps losing out in funding decisions, not because scientists have stopped finding it interesting, but because the practical cost and timeline make it a much harder sell. For now, Webb remains the only working tool pointed back at Pluto, quietly checking in every few months whenever the dwarf planet swings back into view. And almost every single time, the picture gets a little stranger than it was before. It is worth remembering that Pluto sits inside the Kuiper Belt, a vast ring of icy debris beyond Neptune's orbit home to hundreds of thousands of objects and an estimated trillion or more comets, an area of space hundreds of times larger than the familiar asteroid belt between Mars and Jupiter. Only one spacecraft has ever ventured deep enough into that region to closely photograph any of its larger residents, and even that mission only managed close flybys of 2 objects out of the hundreds of thousands of similarly sized worlds believed to be out there. If Pluto is genuinely hiding an unidentified surface chemical shared with a moon of Saturn, actively refrigerating its own sky, slowly bleeding its atmosphere onto a companion world and possibly concealing a liquid ocean beneath a shell of solid ice, there is no reason to assume it is the only object out there doing anything like this. It is simply the one close enough and bright enough for our current instruments to study in real detail. So what does all of this actually add up to? The vote that stripped Pluto of its planetary status in 2006 was never really the end of its story. It just happened to arrive right before the tools capable of understanding Pluto properly were finally built. What Webb has turned up since then is not a prettier picture. It is closer to a diagnosis, and the latest piece of that diagnosis, an infrared signal that matches no known substance on Earth or anywhere else scientists have studied, is exactly the kind of finding that reshapes a field rather than simply adding a footnote to it. Out past the orbit of Neptune in the cold and the dark, there are trillions of other worlds we have barely glanced at, let alone studied this closely. And if one small, frozen, formerly dismissed dwarf planet keeps producing chemistry nobody has managed to explain, it is genuinely worth wondering how many other distant worlds out there are hiding something just as strange. If stories like this one, grounded in real published research rather than exaggerated headlines, are what you want more of, subscribe to this channel and turn on notifications, because Webb is still watching Pluto every few months, and there is a real chance the next round of data solves this mystery, or makes it stranger still. Thanks for watching, and I will see you in the next one.